Welcome back to our classes. That is Ajay Kumar Yadav, and today we are going to AKY classes. Ajay Kumar Yadav. So we are going to discuss about the very next concept of our class is nothing but acceleration. Acceleration. So we can understand about the today's concept as acceleration. Acceleration means what? How will you define it is an acceleration? The rate of change of rate of change of velocity of an object. Rate of change of velocity of an object is also said to be as acceleration. Acceleration. So we can say that the rate of change of velocity of an object is also called as the acceleration, and we know what is the formula section there. Formula section is change in velocity divided by time taken. Change in velocity by time taken. We can write the equation also like a is equals to v minus u divided by t. We can say that v is the final velocity v is the final velocity of the body, u is the initial velocity of the body, and t is the time taken. So a is said to be as the acceleration. Here we can also say that SI unit, what is the SI unit of this acceleration is meter. Change in velocity means measured in meter, and say time is measured in second. Even we can say velocity means 1 by second, so we can write it as ms power minus 2, or we can write it as m by s. What is CGS unit of the acceleration? It is quite obvious, centimeter by second square, or we can write centimeter second power minus 2. And the dimension formula, we can say that it is dimensional formula. Sir, how would be the dimensional formula? Which is nothing but, here we have meter, so m considered as 0. Here we'll consider L power 1 and T power minus 2. So this is about the acceleration, rate of change of velocity of an object. We'll brush up the points again. Rate of change of velocity of an object is said to be as an acceleration, or we can say the formula as change in velocity by time taken. That formula we have written here in the form of an abbreviation as well. So a is equals to v minus u by t. Then we have where v is called as the final velocity, u is called as initial velocity, t is called as time taken, a is called as acceleration of an object. Acceleration of a particular object. SI unit is ms power minus 2 or m by s. CGS unit is cms power minus 2. And the dimensional formula is m power 0, L power 1, T power minus 2. Next we are going to also discuss about the next point of our observation, that is nothing but the different types of acceleration. Sir, what are the different types of acceleration? So what are the different types of acceleration we would like to go ahead with? First we would like to start with the Uniform acceleration. Very first point of discussion goes is uniform acceleration. Sir, how will you define the uniform acceleration? Let us start with the uniform acceleration. If the velocity of object, if the velocity of an object, any object you can consider, solid object or other than solid or planet you can consider. If the velocity of an object is uniform acceleration, if the velocity of an object is said to be uniform if it covers equal distance, equal velocity in equal intervals of time, equal velocity in equal intervals of time. So we can say that velocity of an object said to be uniform if it covers equal velocity in equal intervals of time. We can also say or represent by means of a small diagram. If I consider this is my 0 and if I consider this is my 1, 2, 3, 4. So this is my x1 distance since it is an x-axis. This is x2 distance, x3 distance and x4 distance. The body has traveled 200 meters in the first 10 seconds. Body has also traveled 200 meters in the next 20 seconds. Body has traveled 200 meters in the next 30 seconds and body has traveled 200 meters in the 40 seconds. So obviously we can say the motion is uniform. Motion of an object. The motion of an object is uniform, which is also be represented by means of an, we can say that it is x2 minus x1 by t2 minus t1. We can also write x3 minus x2 divided by t2 minus t3 minus t2. In other sense also we can write like x4 minus x3 divided by t4 minus t3. At last the equation stands there is delta x divided by delta t or dx divided by dt. We can write it here as dv divided by dt. Since it is an x-axis, we are measuring here as velocity. We are measuring here as velocity. So dv divided by dt. Next we are going to talk about the next point of observation goes to the variable acceleration. Variable acceleration. Sir, how will you say it is an variable acceleration? So variable acceleration in the sense, first definition part we'll see. If the velocity of an object, if the velocity of an object, velocity of an object is said to be said to be said to be variable acceleration if if change in velocity if change in velocity is said to be unequal in equal intervals of time, unequal in equal intervals of time. So they are said to be as variable acceleration. Variable acceleration or otherwise called as non-uniform acceleration. non-uniform acceleration. The mean here to understand is, if the acceleration of the object is said to be as variable acceleration if the velocity changes unequal in equal intervals of time. Unequal velocity, we can mention here as unequal velocity in equal intervals of time, they are said to be as variable acceleration. It is said to be as the variable acceleration. So here also we can represent as in the form of a sense, like by understanding this is my 0, 1, 2, 3, 4. So here is x1 distance, x2 distance, x3 distance, x4 distance. So body has traveled 500 meters here in the 10 seconds. Body has traveled 300 meters in the 7 seconds. The body has traveled 100 meters in the 4 seconds, and body has traveled 1 kilometers in the 30 minutes. So this is said to be the best example to define about the non-uniform acceleration. Non-uniform acceleration. Non-uniform acceleration. And that's all about the non-uniform acceleration. Let's talk about the next point of discussion course is nothing but average acceleration. So how will you find the average acceleration? Average acceleration, how will you represent this? We can represent the average acceleration if the velocity, if the ratio of change in velocity, ratio of change in velocity to the ratio of change in velocity to the change in time taken. So we can also write time taken, that is also called ratio of change in velocity by change in the time taken, or else you can write in other sense also, like ratio of total change in velocity, ratio of total change in velocity, ratio of total change in velocity to the total time taken. Total time taken, they are said to be as the average acceleration. And here also we can represent by means of a small graphical section. This is my 0 or x0 I can consider. Suppose the body has traveled, same thing I can consider, sir, 500 meter in 10 seconds. Next, body has traveled 300 meters in the 7 seconds. Next, 100 meters in the 4 seconds. And at the last, body has traveled 1 kilometers in the 30 minutes. So we can say with respect to this also, it is almost will be same. 500 plus 300, 800, 800 plus 100, 900. So 1900 meters, which is traveled in 30 30 minutes, 10 seconds, 17 seconds, and the 4 seconds. So we can write it here as 30 minutes, 30 minutes, 30 minutes, and 21 seconds. Sir, if you still want to understand this concept, that is 500 meter plus 300 meter plus 100 meter plus 1 kilometer divided by 10 seconds plus 7 seconds plus 4 seconds and followed by 30 minutes. In that sense also you can able to write the readings there for your average acceleration. Next, we are going to discuss the last part of our class, that is called as instantaneous. Instant, instantaneous acceleration. Sir, how will you define the instantaneous acceleration? The instantaneous acceleration we are going to discuss here is nothing but the change in velocity. The change in velocity at that instant of time. The change in the velocity, change in velocity of an body, or object, of an body, of a body or an object, or an object, uh, at that instant of time. At that instant of time, they are said to be as instantaneous acceleration. We can also write it as instantaneous acceleration or change in the path, or we can also write in other sense. If you want to write it in other sense, the change in velocity or change in the velocity of an object, change in velocity of an object of a particular point of its path, particular point of its path, of its motion, we can say, of its motion. They are said to be as an instantaneous acceleration. Instantaneous acceleration means change in velocity of a body or an object at that instant of time, or a change in velocity of an object of a particular point in its motion. They are said to be as the instantaneous acceleration. Sir, can you explain in the understanding graphical sections, like if I have traveled the body like 10 kilometers, the whole time duration I have taken as 10 kilometers, and the time duration I have taken is 2 hours. So I want to know 31st minute. I want to know 31st minute what is the velocity. What is the velocity? If I want to know the 31st minute what is the velocity, that is called as, indicated as instantaneous acceleration. What is the velocity at the 31st minute? That is called instantaneous acceleration. That can also be represented by the equation, as we know very well, that is A is equals to delta Vx by dt under the limit delta x tends to 0, or I'll write you in other sense, limit delta t stands to 0, where we can write the equation as, where we'll write the equation as delta v divided by delta t, or we can write dv by dt. Since we know very well, we can write the velocity in other sense. In the next sense we can write there, that is acceleration is the first order derivative, first order derivative first order derivative of velocity, that is change in velocity, first order derivative of change in velocity of a body, velocity of a body, and second order derivative in the second order derivative second order derivative in change in position of an object, change in position of an object, position of an object in a given time, in a particular time. So we can also say that Acceleration of an object. Acceleration is the first order derivative of change in velocity of a body in a particular time span, or second order derivative. First order derivative you can understand, that is delta V divided by delta T. That is first order derivative. And what is the second order derivative? The second order derivative means d square x by dt square. So we can also see this derivation in the next page, that is nothing but we can write here as acceleration is equals to delta v divided by delta t, or we can write dv divided by dt. If I want to write dv divided by dt in the sense, I can write here as d by dt of n dx divided by dt, since we know that velocity. So we can write here as d square x by dt square. So what is my acceleration would be? Acceleration equal to d square x divided by dt square. So with this sense also I can define my acceleration. Let us have a discussion over the brush up the points related to different types of acceleration. Very first point we have discussed here is uniform acceleration. If a velocity of an object is said to be uniform acceleration, if it covers equal change in velocity in equal intervals of time, motion of an object is said to be uniform. The equation is dv by dt. Next we have discussed about variable acceleration, otherwise called as non-uniform acceleration. If the change in velocity of an object is said to be variable, if change in velocity is said to be unequal or in equal intervals of time. In other sense also you can write like equal change in velocity in unequal intervals of time. In the either sense also you can write. And this is the equation you can represent there. Average acceleration means ratio of total change in velocity to the total time taken. Total change in velocity to the total time taken, it's called as average acceleration. And instantaneous acceleration means change in velocity of an object at any instant of time or point of its motion. Change in velocity of an object, particular point of its motion. We can write this derivation also like dv by dt. In this sense also we can write like acceleration first order derivative of change in velocity and second order derivative of position of an object, position of motion of an object. This derivation also will be really helpful to define about the acceleration equal to with respect to position of an object. So this is the definition, actual definition which you have learned so far. Now in this sense also you can able to write, sir, how this will help? This will help only through the problem solving equations. And we can also say that acceleration is positive. When can we say acceleration is positive? If I say acceleration is positive means change in velocity is also positive. If I say acceleration is positive means change in velocity is also positive. That means we can say takeoff of an aeroplane, or takeoff of an aeroplane. We can also say that a train has left the station, train has started from the station, rather than we can say started from the station, that is called as the positive acceleration. We can also say that acceleration is negative. How can we say, sir, the acceleration is negative? Change in velocity will be negative there. Change in velocity will be negative there. They are called as the acceleration is negative. We can say that landing of an plane. We can say that landing of an aeroplane, or we can also say that train has reached to the station. Train has reached or destination reach to the station. They are called as the example of an positive acceleration and negative acceleration. Even you can write it as zero acceleration also, like change in velocity is zero or velocity is constant. Like if I say velocity is equals to constant, velocity is constant. If I write the how will I calculate zero acceleration, I would like to go with the zero acceleration. Means how can we define the zero acceleration? We can say that a equal to dv divided by dt. We can write it here as d by dt of constant. If I say d by dt of constant, differential of any constant will be considered as 0. So my a will be 0. In this sense, we can define the zero acceleration. So I hope you could have liked this class. Hope you could have understood a bit from this class. So how would you feel about this? Don't forget to comment on this comment section. That's all about the acceleration class. Hope we'll come with the next topic in the upcoming classes. That's all about the today's class. Thank you very much. Thanks for watching this channel. We'll meet soon with the next session with the next topic in a short span of time. Thank you very much and thank you very much for the today's session.